Welcome back. I think people are still going to filtering in from the break. They're enjoying their special brownies and cookies, whatever's out there. Welcome to the second session of TEAS. I am still Lou Berger, still Pavan Bira, and we still have Matt helping us out as secretary. The only thing I'm going to cover here is our note well. Every session of the IETF, we're asked to remind everyone of our rules governing contributions. They haven't changed since the last meeting, the last session, but if you're unfamiliar with them, please look at the note well, a URL on the bottom. We are continuing to do Etherpad. The interesting thing is that there was a transition from one server to another server, and some of our links got updated and some of them didn't. If you happen to jump on the Etherpad that is not the one where everyone's taking notes, it'll say, please go to this other page. And this is actually the one we're using. And with that, Daniele is up next. Does it work? Yes, it'll work.
Welcome back from the cookies. This is Daniele. I'm going to give a very short recap of the packet optical integration work that we are doing, or better, that we revived. This is something that we started a while back. It was not good timing to address the problem, so we are reproposing this work now. So what's the scope of the draft? The title was not a very good choice, in the sense that we are talking about packet optical integration, but the scope of the draft, at least at the moment, goes a little bit beyond packet optical integration. So this is for sure something that needs to be fixed. And you'll see at the end that there is a number of open issues that we need to address in this document. Basically, what is covering now is applicability of ACTN to packet optical integration. So basically, having an MDSC talking to multiple PNCs at different layers in the network. Packet, optical, OTN, whatever type of layers. And then also how this how ACTN interworks, deals with things beyond its scope, but that will always coexist in the network. We are talking about VPNs. Basically, ACTN just deals with what we refer to as the underlay traffic engineered infrastructure, which is something that you provision in most of the cases because you want to create a VPN, layer 2 VPN, layer 3 VPN. And so this is the document where we tried to identify how the things live together. And then a little bit of terminology. So how service orchestration and network orchestration work together in this contents. I've already covered the next bullets. Basically, the scope of the draft is to define a reference architecture for packet optical integration, which includes ACTN components. So what we said before, the underlay traffic engineered infrastructure, and the non-ACTN components. So like the creation on VPNs on top of that. This is the reference architecture we were talking about. So basically, we have defined this domain controller and hierarchical controller, and we said in the framework that the PNC is one of the functionalities of the domain controller. The MDSC is one of the functionalities of the hierarchical controller. namely the functionalities in charge of traffic engineering, so doing path computation, provisioning T-tunnels, provisioning virtual networks, etc., etc. And you see how these things interact with what is known as IETN, which is what is blue in this picture. Actually, we tried to put the things together in this sense. You see, the red part, so the MDSC and the PNC, this maps one-to-one with the ACTN architecture that we have in the framework. While the blue part is the provisioning of services. Actually, two different methods can be used, identified with the number 1 and 2 in this picture. Basically, number 1 is what uses a network model. So an hierarchical controller asking a domain controller, please create a VPN. Number 2 is the controller going directly to the nodes using device models to configure the services in the network. This is another thing that we wanted to point out, which is the fact that we are not talking about different interfaces. The interface is one. There are just simply different young models used. ACTN models are models A, B, and C. We have other models, E, F, and G, to do something else. For example, the L2SM and the L3SM for the creation of layer 2 and layer 3 VPNs. In the draft, we try to, so once we define a quite generic scenario, multiple packet domain controllers, multiple optical domain controllers, an hierarchical one, we try to identify a workflow, basically. What is the process? What are the interfaces? What are the different steps in the provisioning of such a multi-layer environment, multi-layer structure? This is something that you can see in the draft. I would like to save some time and go directly to the conclusion and next steps. So, issues addressed by the draft. Applicability of ACTN to packet optical integration and services, VPNs. Role of packet optical integration in hard and soft isolation scenarios. This is something that I didn't cover during the slides, but is one of the issues that is addressed. Open points, open issues. So these two items, VPNs and packet optical integration, do they need to be addressed in the same draft, or there is enough meat to split the work into two portions? Considering also the fact that another draft on packet optical integration was recently published, I read it this morning. It's a very good document, so I think there is room for let me say integration between the two documents. So what do you think? Should we address VPNs in a document, packet optical integration in another, address just one of them because it's more important than the other? We are totally open to get feedbacks and start and steer the work towards the right direction. This is a 0-0 draft, so there is still room for improvement, for changing everything, dropping everything. Hi, Michael. Welcome back.
My name is Michael Schraff. I'm not sure if you care about the opinion of an academic, but if you want an answer from an academic on these two questions, I would say yes first. Also, there is value in splitting this because these are clearly orthogonal things. Of course, at the end of the day, you can come up with a workflow that does all this, but if you look at it in detail, you see that these are sub-problems that can actually be solved pretty well independently, and in reality, there's a high likelihood that those problems are solved independently. Also the VPN provisioning on the one hand side, and everything that deals with packet optical on the other side. So I would strongly argue to split this. And regarding the second question, add more packet optical use cases. There are quite a number of relevant IP optical use cases. And what you have in this document here is probably not the top relevant list. So if you look in the market, if you look at commercial solutions that exist, if you look at what operators typically deal with, then what is in this document is not the top priority. This is probably the use case 10 or 20, and there are 9 or 19 use cases that are low-hanging fruits and higher priority. So I would strongly argue, yes, look at other use cases and maybe in another document.
Yeah, so I revert to the question in the sense that the goal here was to create a generic use case, a generic environment, a generic scenario, and try to address it. So are you saying that it would be better to define a set of use cases and then for each of them go into the details, so do something specific rather than generic?
Yeah, I think there's strong value in coming up with a realistic list of packet optical use cases. And as I said, there are in the market, there are of the order of 10 use cases that are very well known. And it definitely makes sense for me, as in this working group or another working group, to document that. But my key point is, the starting point is probably not the use case that is in this document. So there are other use cases out there, and I would suggest to start with the other ones because they are more realistic, they are low-hanging fruits, and they are closer to the market needs, at least as far as I know.
Okay.
Thank you. Itar Buzi from Huawei. I agree on your proposal to split into 2 documents because VPN over ECTN is not only packet optical, cannot be over just a layer 3 network. And a packet optical is not only VPN, it can be also infrastructure. So the 2 problems are quite different, and it's better to have 2 documents and to document both because both are really valid problems. Thank you.
Personally, I'm a little bit worrying about whether we can do really good splitting. Okay, clear? Whether we can do really good splitting, because VPN is very specific and we know what it is. But POI, packet optical integration, there are a lot of possibilities that we can consider different scenarios as a POI. So we need to have a clear boundary if we really make the decision to do the splitting and make sure that we don't conflict with each other.
Okay.
Dhruv, Huawei. My comment is regarding your slide 3, where you were showing the MDSC directly talking to the device. And there was I think a slide before that. Yes, this one. So where the difference between 1 and 2. So based on your feedback, because L3NM was something which was discussed in RTGWG and might be in Ops area working group, where the idea of a VPN network model came up. So right now, were we doing 2 because we did not have an L3NM, or is this something that you believe is the right way that maybe the top controller can directly talk to the device?
So I would say that in an ideal future, probably 5 years from now, all the domain controllers will have the capability to create VPNs. So most of the interfaces will be number 1. 5 years maybe is not enough, maybe also 10. In the meanwhile, number 2 is definitely needed.
Igor, I also was on this routing group session, and I heard Oscar's presentation. What I didn't understand and still don't understand this idea of layer 3 network model, because model is basically an API between 2 controllers, right? So basically, if you a controller that have to talk to many different people, so then you have to have different models, right? I cannot see which side. Probably orchestrator is on one side, but what would be on the other side of the layer 3 VPN network model, I don't understand. So that's why my question was, why do we need this model at all? So I think basically what you have on the picture is correct one.
What is in the picture is the right one. What are you referring to? Sorry, Igor.
I mean, what I mean is that MDSC can definitely talk to devices whenever there is a need to, for example, attach service to tunnels produced by other models.
Okay.
I kind of disagree, Dhruv again. Based on even during the implementation side, we faced quite a bit of issues when we were trying to do that, and not having an L3NM model just created too much of confusion from the implementation side as well. Because you have a domain controller, its job is to talk to the device. For T model, for everything else, you are relying on the domain controller, but with respect to VPN configuration, you directly hijack them and directly send to the device. So it was becoming, didn't feel like the right approach. And anyway, L3NM discussion doesn't belong in this working group, so we should not take too much time about the applicability of that. Thank you.
Okay.
Daniel King. So just wanted to echo a theme that seems to be occurring this week, is that the IETF, in regards to sort of modeling services and then sort of developing the device models themselves, kind of loses some of the integration and some of the operational issues. We're very good at sort of fragmenting the problem space and developing a device model, and it's a very good device model for a very specific piece of equipment, but we often lose sight of the end-to-end service, and sometimes it's quite difficult to actually map the models together in order to develop the service. So we hear this from industry that actually Yang's not being used, or the Yang IETF models are not being used because the IETF doesn't understand the system. It doesn't understand the end-to-end service. So I think we do need these documents. The second comment is, as a co-author of the other packet optical integration document, I do think there's some synergy between both of our documents here. One maybe to look at the end-to-end service, and the other to do sort of some of the detailed gap analysis of which models do you need to combine in order to provide a particular use case or solve a particular use case for packet optical.
Thanks.
Italo Busi, I tend to agree with Drew on the interface number 2. The risk I see here is consistency in terms of naming, because the PNC on domain number 2 is doing some abstraction. So the MDSC may not even be aware about the box which is terminating the tunnel, and therefore we need to have, maybe just for naming translation, maybe very simple, but something in domain controller number 2 that takes the configuration of the VPN service and translate that into the device configuration. I think it's we move the complexity of naming consistency, and that's maybe it's better to go with number 1 and allow a lightweight solution if in case you think it's too complex for the domain controller.
Yeah, well, as I said to Dhruv, ideally, I agree with you. Ideally, having just interface number 1 would be great, would work. The thing is that there is plenty of commercial implementation today with interface type 2, so they work. Less than 1 minute.
Great, thank you. I think based on that, we look forward to seeing what happens with some restructuring, maybe some combining, maybe horse trading. But we look forward to seeing the next update on this.
So, go ahead. Okay. So this is the applicability of ACTN to support 5G transport. It's a 00 draft that Yang and I wrote. So let's get to the problem that needs to be solved. The question is basically how we map the 5G slice instance to a transport slice instance. And if you look at from the 3GPP or the 5G side, a slice is defined as an end-to-end logical network comprising a certain set of resources and so on. It's defined in 3GPP documents 28, 531, and so on. So that would mean that it's across from the handset to the base station to the user plane device like a router, and all the way where the PDU session exists. And on the other hand, the transport network slice instance is, as I guess, you probably have looked at in more detail, across a transport network itself, across 2 points, or resources across multiple points in there. If I had to look at it this way, you could think that between the base station and a user plane device in the 3GPP network, we could think that there's a transport network and another transport network from that user plane device to the application server. But that would still be the same 5G slice. And on the flip side, you could say that the transport network is not only serving a 3GPP or a mobile operator, it's serving other clients as well. So there needs to be a mapping between what a slice means in the 5G domain and what resources are reserved or provided in the transport domain. And I think that's what we're trying to do here. So if you look at the details are really in the 3GPP documents, there's the network slice identifiers like the NSSAI, the QoS identifiers like 5QI, and all of that put together defines what should be provided in a PDU session. And the transport between two of these nodes may cross more than one network, layer 2 network. So for example, it could be a data center network followed by a backhaul network and another data center network between those two functions. So in considering this, I think we think that it's better that we carry this mapping info in some kind of an IP layer, header extension or some other way, so that you don't have to map between the different layer 2 networks. So what we're defining here is a context identifier called the mobile transport network context. And this identifier maps a class of service, if it's a QCI or a 5QI, I meant to write 5QI actually there, and slice aspects of a 5G slice and other QoS requirements, including reliability, isolation, security, and so on, to a VN slice in the transport domain. And it's up to the 3GPP or the 5G domain to generate this identifier based on, and all of that would be in the 3GPP network because they know the users and the subscribers and how much differentiation is needed. And so based on that, it can generate these identifiers and request for service to be offered in a transport network. So that would be a contract between the 5G domain and the underlying transport domain. Note that this is not a one-to-one association between the PDU session. The PDU session is in the 5G domain, and the identifier that maps to the transport domain. So there will be multiple to one, so many flows to one. And I think that's the basis for saying that the identifier would scale well, because it's scaling by the square of only the number of associations in the transport, and the flows will be much higher than that. Also, the identifier is generated before the session is established, and so there is no need to figure out where that path is when the session needs to be established. So those are I'll get into the little more detail in the next couple of slides, this one and the next, and to show how this can work. So I think on this slide, I will not go into too much detail because it was presented in much more detail, I think, in the last presentation, at least from the point of view that I want to focus on, which is the CNC. The CNC is the point at which the 5G network interface, or there's another entity in the 5G domain with which this will have a contract for a slice or set of transport paths. So that's the focus. I mean, I think this figure is pretty familiar to people here, so I won't get into much detail here. But just note that the CNC, is the session controller in this, I mean, the SDN controller in this document. So I'll just briefly go over the figure so that it's easy enough to follow. So all that's in that blue box is 3GPP specifications. And that's why I'm trying to avoid getting into the details over there, because that would have to be specified by 3GPP. But let me start with the TPM and the action one, where the TPM is a transport path manager, which estimates how many slices and how much bandwidth and other resources are needed between 2 points. Based on that estimation, it generates the MTNC and programs or gets a contract with the SDNC to deliver the services across a transport path. So that's what the TPM holds. And the SDNC, I guess, in turn programs the underlying transport backhaul and between the PE routers. On the other hand, there's a 3GPP nodes that manage the session, which is the SMF and then the user plane devices. So when a handset or a UE sets up a session, it's a session management function that manages that function. So the session manager programs the underlying transport path MTNC or the ID, and that's what is delivered when a session transfers from the user UPNF on one side to the other. I don't know if there's a simpler way to explain it. I mean, there's 3 sets of actions. So one is to program the MTNC identifier, the TPM to the SDNC to the PE router. So that's the provisioning part. The other details are in 3GPP, so I'll skip that. And when a packet arrives at the UPNF, it could be a base station or a router, let's say. So that classifies that session packet, and based on that classification, the MTNC identifier is inserted. And when the MTNC ID is presented to the PE router in step 3, it grants the resources that was reserved in the transport network. So that's the sequence of operation. So to do this, we also need to be able to carry this identifier in the IP packet in a suitable place where it can be read pretty easily and the transport network can program. So for example, in this case, the 2 UPNF functions are the Gnode B and the UPF on the figure up there. And that's an N3 interface between. So when a packet arrives at the Gnode B, it gets classified and an MTNC identifier is inserted based on what the 3GPP network is programmed it with. Then when the packet goes to the PE router, the MTNC identifier is inspected and the appropriate forwarding label is put in. The appropriate forwarding label is inserted. So we chose this method because many of the other ones are not suitable. GTPU is not a good one. DSCP does not, or the flow labels are not immutable. And we think that either a GUE, SRv6, or maybe other such extensions are the right ones. So I think this is the first draft. I mean, we think that there's many holes to be plugged in here, and the use of GUE and other things, and we're looking for feedback on all of this. This was more from a transport side, and I'll be presenting a similar case from the mobile transport in the DMM session, the counter of this, with more details on the 3GPP side.
Hi, Tom Herbert. So in terms of the mechanism, IPv6 extension headers could be a possibility. In fact, I wrote a draft called Firewall and Service Tickets. I'm not sure you've seen it, but it's almost identical to this. The idea is we carry some sort of identifier that provides QoS and even routing information inside an opaque value, and that's carried in an IPv6 extension header. It might be worth looking at, so we could discuss
Absolutely.
that offline if you want.
I agree. I mean, I'd like to talk to you about, is this a fast?
Fast firewall and
okay.
service tickets. So I presented it in int area. I really didn't know what the correct home is. Seeing this working group for the first time, this might be an interesting location for it. It would serve a lot of the same aspects. It also has some other features. I would intend this to actually be going to the application sending this, and then we have some mechanisms to reflect it. So the return path is always another problem with stuff like this.
I'll look for you. I mean, those are areas which we need more feedback. I mean, this mechanism is basically about how to send the MTNC itself, and we're looking at the right way to do that in an IP packet. So I'll try to reach out to you.
So it's nice that there's options, but that's also a problem, right? So we have GU and SRv6, and then somebody want to do this in MPLS, and many options. The value or proposition of IPv6 extension headers, like hop-by-hop options, are do it once and it should work. In all use cases for IPv6, IPv4, it's another issue that we have to solve.
I'd like to add only one other thing is we want to do this for IPv6 and IPv4.
So like I said, IPv4 is a separate question. I do have some ideas on that. We could talk offline also. But it would be nice in the end to have one common solution instead of a fragmented solution.
I'll talk to you. Thanks.
All right, great, thank you. Reza?
Good afternoon, everyone. My name is Reza Rokui. I'm at Nokia, and on behalf of co-authors, I'm going to present transfer slice connectivity. Okay, it's better now? Okay. So maybe power can. It's okay. So here it says interface, but it's really interfaces. Before going through the detail of the draft, there are a few comments. One is that recently there is a project accepted by BBF, which is in the same area, and we feel that whatever we do here should complement that. So this is one of the specific topics that is very important to be considered. And as I go through the presentation, I will show you how this one relates to whatever we do as IETF, and the work at BBF and IETF should be coordinated as well. So this is basically the starting point. It's somehow related to the previous presentation. They talk about network slicing and transport, and I'm trying to just give you another perspective of how everything relates to each other. So you've seen this picture or a version of this picture most likely in the different the context, but I'm trying to mention here that what is end-to-end network slice, basically the representation of a logical interfaces from left to right. Left is UE. Let's say there is a mobile network operator, has three customer or tenants, BMW, Fiat, and public safety. Each of these tenants are asking about various independent logical network from UE all the way to application. We call each of these independent network end-to-end network slice. It's very important. End-to-end means network slice from left to right. Each of these network slices, I have various colors here. You can think of color as SLA. Each one has a specific SLA. And each of them has various subcomponents. RAN slice, sometimes they call it RAN sub-slice, or RAN subnet is the same thing. Core slice, and transfer slice. RAN slice means in the RAN, depends on the deployment, I'm creating a personality in RAN to understand each of these network slice. By the same token, core slice means I'm creating the personality on my core equipment. The equipment is different, configuration is different, but the logic is the same. And last but not least, there is a transport slice. We talk about, when at IETF, we talk about network slice, basically we are talking about the transport slice portion of that. That one is a set of connections. As you will see here, there are various connections that should be happen between RAN and core, or sometimes inside the RAN, depends on the deployment of RAN, I have to create so-called mid-haul or front-haul connectivity. So, long story short, you will see an end-to-end network slice contains RAN slice, core slice, and transport. Each of them has its own controller. The focus of this presentation is the transport slice, which basically gives the connectivity, and we want to address that. Yes, please.
Sorry, Igor Briskin, clarification question. So I hear this for the second time. What I don't understand is when you write this line, right, like the segments, is it actually point-to-point connection, or each of these segments represents a topology? So basically, you may have multiple connectivity.
The latter one.
Okay, so it would be better if you would draw it like a little topology.
Yeah, but this is a very high level to at least give a perspective. But the point is taken. So this is a better picture for one of those transport end-to-end network slice. Let's say I have a mobile network operator X. There is a company Y, tenant Y, wants a type of service URL C, low latency, and my SLA is latency less than 5 milliseconds. How to create that? The network slice and the component artifact is not created in the network yet. So from the top to bottom, if it's a PowerPoint, it has animation, but I'm trying to go through the animation, basically the logic here, starting from 1, and the note yellow is important. This are logical steps, doesn't mean necessarily happening in the sequence. From the top to bottom, customer asks about the service, orchestrator, which is the end-to-end context, go through some action using the network slice blueprint, aka network slice template, is creating a profile. Profile says what are the components should be inside the end-to-end network slice. And after that, it goes through a step 3, 4, 5, 6 to basically create them or configure them. The important aspect of our discussion here is comparison between interface 4, 5, and 6. Interface 4 and 5 is basically creating the RAN and core slices, the context that we're creating on the RAN and core. They are well defined in 3GPP, and the context of this discussion is interface 6, that we are sending that one to a transfer slice controller, and we want to create the connectivity. Interface 6 is not defined in 3GPP, and basically the work that we want to do is defining interface 6, which is basically aligned with interface 4 and 5 for the RAN and core respectively. So whatever we want to do is basically that this is another representation of same logic. These are taken from 3GPP. On the left picture, you will see that whatever 3GPP talks about transport is that dashed line. Basically, this is a definition of the transport connectivity that we want to explore. On the right-hand side, bottom right, is basically the same picture that I showed you before. This is taken from the 530. It's basically demonstrate that whatever we want to do for transfer slice is aligned with 3GPP. Same picture, at the very top, we have orchestrator and we have 3 domain controller. If in 3GPP lingo, sometimes they call the end-to-end network slice orchestrator NSMF, network slice management function, and they call the 3 components for RAN, transfer and core NSSMF, network sub slice management function. So go ahead, please, and after I finish this.
Just a couple of questions for clarification. Do you view this as one domain between the transport and 3GPP? That's one question. The other one is whether these slices are more dynamic or programmed and left eye.
Sorry, with last one, that definitely is dynamic. The whole dynamicity is here. Nobody goes and creates with CLI or configuration of transfer slice run. Everything starts from the dynamicity of the whole logic. And the answer to your first question is multiple domain could be possible as well.
Then it's pretty complementary to.
Yes, yeah, maybe we can talk offline as well. I want to ask you a few questions previously, but we can talk about that. So the idea here is the important aspect. This picture is trying to say that each of these orchestrator or controllers has three functions or three major capability: automation, monitoring and analytics, and optimization. In other words, when we are talking about, for example, the red, we want to talk about transport slices. That we should talk about not only the automation or creation of that, but we have to talk about how we can monitor and do the analytics, aka open loop, or how we can do the optimization, aka the closed loop. So these are three major functions that should be addressed. And in most cases, we are addressing only the first one, but we are somehow ignoring the second and third one that we have to address at the same time. Okay. I need only a few minutes. So basically, these interfaces that I put it here in red, is the question that we have to address. It's missing from industry, is needed for the industry, and how this relates to IETF and the work that we've done in the layer 2, layer 3, layer 0, layer 1 services. This is a kind of complementary to that. Why? Here, again, if it is PowerPoint, there is animation, but consider the yellow end-to-end network slice that we want to create. To do that, we have RAN, core, transport controller. We have to create these three components and connect them together. Basically, go through the transport controller, because this is the discussion of this. We send a request to transport controller to create connectivity between RAN and core. We don't, in that interface, we don't specify create a layer 3 service or layer 2 service. We just say create connectivity between RAN and core, and the SLA is 5 millisecond latency, for example. Transfer slice receives that request, translate that one to some artifact that can be deployed to the network. This is a requirement that we have to work here. And step 3 is basically whatever IETF has. IETF has various models and way to deploy this connectivity to the network. And this is basically the idea that whatever is proposed here is complementing IETF. IETF is defining the whole service, tunnel, path, how to do it, the various ways to do it from layer 0 all the way to layer 3. But basically, we are trying to say that this one is a complementary to IETF. So in summary, we have to address automation, monitoring, optimization. And whatever we do is basically complementing the IETF. These interfaces are needed for the industry. And I didn't put it here because I created this slide yesterday, but we have to work a kind of liaison between us and BBF to address the synergy that is there, and why the draft is in this working group, because with the knowledge and expertise that is existing here for various young model, various model that can be done, basically we can take the requirement and somehow use this knowledge and augment the model that we have here. So basically this is the reason that I'm presenting it here. This is end of the presentation. I'm more than happy to take questions.
We have about 2-3 minutes for questions.
Yeah, I'm checking with authors whether you have detected any gaps so far with models has been specified in this working group with your requirement.
Yeah, there are. None of the model today addresses the requirements that we need. All of them should be augmented. In other words, the information that is needed for the related to a specific end-to-end network slice, a few attributes, the multiplicity of the services that we have to create. any model that we have can be extended and augmented there. Which one is better? I have some opinion on that one, but basically today's model is not addressing that. It should be augmented. So this is the
Could you please just scroll up to a few pages into some kind of architecture? Yeah, maybe this one is good. The next one, yeah. Yeah, I think this one is something about the controller hierarchies, which is, if we generalize this, it can be something similar discussed.
Yeah, definitely, and this is the reason that we are presenting it here.
So that's my question is, currently we have the T models, we have the VN models, we also have the layer specific service models specified in other working groups. And my understanding so far is a combination of the VN and the service models can satisfy this kind of requirement. But the only difference is we are using this kind of models to support different service with different technologies.
I can say we are supporting different connections which are implemented, aka realized by a service tunnel and path. So we have to make a distinction between connection. There is a subtle difference here, at least in the context that we have here. But basically, whatever you mentioned is correct. So this is a kind of complementary to that hierarchy that we have today, and basically the different use case to address the different use case in the context of 5G. I hope I answered your question, but if not, we can have offline. Eric, please.
Hi, Eric Gray, Erickson. So I attended this presentation a couple of times, and I've also been attending the presentations in the broadband forum as well. One issue that I see here is you have been talking in the past and about an abstract interface, which is, in everything I've seen about it, really describing a service interface. You're talking about an interface that says, I need this capacity, I need these delay parameters, et cetera, et cetera. This is done in a way that's orthogonal to the actual devices being used in the network. Mm-hmm. And so in going to the broadband forum, what the broadband forum seems to be looking for is, so what we can provide is a mapping from that abstract interface to actual devices in service provider networks. Now we come to the IETF, and they're saying, well, we already have, as far as I understand it, we already have a number of models that sort of support this. What exactly is it that we don't have? And so what I see going on is we're trying to do all of these things at the same time. And in fact, it seems to me that what you're wanting to do is sort of have a top-down development. And if you're having them all done at the same time, I don't see how you can effectively do that without spinning wheels for quite a while, unless you know exactly where it is you think you're going to end up. And I don't think that there's a lot of belief in this room that we know exactly where it is we're going to end up.
And this is basically the whole idea of that we have to study all those things. The fact that we need a single set of interfaces, abstract interface, which is aligned with 3GPP RAN and core, is basically the idea here. That interface should be, in most cases, abstract, vendor agnostic or technology agnostic. And basically we take that, as you say, the mapping, and this is step 2 here, is exactly whatever should be done at the transport control to the whatever you mentioned, to the map that interface to a specific implementation that we want to do. And this is absolutely correct. We have to study that to see how that mapping should happen. But the fact that there is a model abstract which should be mapped to a more specific one, how to do it efficiently, and how BBF can work with IETF, or how we can do that from the mapping is under discussion, and we have to study that one. I cannot say we have all
there's nothing in what you're saying that I completely disagree with. The issue is that when you gave this presentation earlier, you were actually talking in timeline where you were actually expecting to begin protocol work or gang work or something like that at the next IETF meeting. And I don't see how that's realistic, given the need to sort of figure out what's there and figure out what is missing coming from a top-down approach, where you have 3GPP defining exactly what it is that they're looking for from a transport in terms of service parameters. And then you have potentially other organizations, MEF, TMF, whatever, that are going to want to have a say in that. And then you have the Broadband Forum doing its piece, and then you get down to the IETF. If you try to do all of those at the same time, which you'd almost have to be doing if you really expect to do any work next time at the IETF meeting, you might be just a little too optimistic.
Yes, but we will see.
If it's
There
really,
is a last question.
I have a clarification question, but you removed the slides, but I'll talk to him later.
We can do
Okay,
it. Okay.
great. Thank you.
Thank you very much.
I was putting down you there. There was something behind you. The other mic. You're directly in my
Good afternoon, everyone. I'm Zan, comes from ZTE. I will talk about the packet network selection using segment routing. Next, the figure below is the layered architecture of enhanced VPN, which is defined in draft TEAS enhanced VPN. Based on the layered architecture of enhanced VPN, this document specifies the solution to create virtual network in a packet network. Introduction: explicit virtual network identification, administrative instance identifier AI to meet the different service in entire network, which is not only in IGP domain, but also in cross-domain case. AI is one of constraint criteria of the color template. And a color template with AI provides a more flexible control. Virtual network-based MP2P SRBE for best effort service and P2P SRTE for traffic engineered service respectively. Uniform color template, centralized and distributed intra and inter-domain for overlay service mapping to underlay results. There is no modification to the forwarding table. In order to distinguish the forwarding behavior, the prefix SID will be allocated per AI. Next, this is an example of our solution. In figure, there are two topologies, red and blue. Red topology includes A, B, C, D, E, F nodes and link A, B, B, C, B, F, B, E, F, E, C, E, and E, D. The blue topology includes A, B, C, D, E, F nodes and link A, F, F, B, F, C, F, E, E, C, B, C, and C, D. The controller connect the resource information with AI through BGP LS, and it can build corresponding SR virtual topology and can calculate the SRTE path based on the color with AI and other constraint criteria in each virtual network. The next is multi-domain deployment. It is easy to provide the end-to-end virtual network, including the inter-domain. In some deployment, the operator adopts the BGP LU to set up the BGP LSP. If the overlay service can directly over the BGP LU LSP. If the overlay service has the requirement of the TE, which defined by a color, the BGP LU will also support the color, and the BGP LU label will allocate per color. The below is the option B inter-area. It can also provide end-to-end virtual network, including the inter-domain link. The inter-domain link can choose the link based on the color with AII. Next is the end-to-end SRT with SDN. The decontroller can connect the topology information with the AII through the BGP-LS and then calculate the SR path based on the information. Next is combined with SR flex algorithm. The color template with AI could map to the FAID for label stack optimization. With the algorithm value advertised is flex algorithm value. The prefix SID is associated with passes calculated using the flex algorithm in the associated topology AI specific. Next step, comments welcome. Thank you. This is the end of our presentation.
Tarek from Juniper. How do you assign certain bandwidth to a SR flex SID? Like for the slice. So if a slice is requesting certain bandwidth, how do you do accounting on per SID?
Sorry.
We can take it offline if you don't have the answer now.
Sorry, again, can you discuss with the mail list?
Yeah, sure.
Okay, thank you.
Okay, no problem.
So we've been grappling a little bit on what to do with these drafts because as you see, there's a fair bit of discussion, a bit of difference of opinions on which direction, but we also think that there's clear interest in work in this area. And in fact, I guess I should confirm that. How many people think that we should be working on support of 5G or slicing? Quite a few. So the chairs read the room correctly, even without asking. So it's always nice to be right, but it's good to be. It's even better to have that confirmed. So we've been grappling with how to proceed with what we thought was the intent of the group, and now we know is the intent of at least the room. And we were thinking that perhaps the right way to proceed is to come together to collect those people who are interested in working this into some sort of design team and to come up with a stated direction. So the objective of the design team will be come up with a direction for the work in this working group. So it's going to be a fairly open, and we would expect a little contentious because there's a bunch of different views here, to come up with a proposal that is consolidated among those people who are very interested in working on this problem, come up with a proposal of what this working group should be doing. Now, of course, generally design teams, while they can be just put together by chairs, we typically get input from our AD, who hopefully Deborah is there. And this is something we'll have to work between now and the next IETF to put together. So we're not at the point of announcing a design team. We're suggesting that the design team may be the right way to go. Part of that will be finding out folks who are interested in participating. And we're going to need a sort of a balance of people. Those people who have a good understanding of what's happening outside the IETF, and of course those who have a good understanding of what we've done previously inside the IETF and even beyond this group. So at this point, we would like some feedback from the working group if they think that's a good idea, bad idea, any comments they may have, or you may have. Comments? All right. How many people think that or who thinks that this type of approach that I've outlined, I agree that it's very high level, but that approach makes sense. So that looks like a pretty good number. How many thinks it does not make sense? All right, Eric's hand went up and then it went down. So no one. So I think that's a pretty good endorsement of that direction. We would ask that you send a message to us at the chairs list. So that's TEAS chairs if you're interested. Once we come up with a formal charter and a little more structure, we will send out a formal call. But we are explicitly saying, don't wait for the formal call. If you're in the room, if you're listening to this, feel free to drop us a line. We will be sending out something to the list to make sure that even those who are not in the room have an opportunity to participate.
Igor Breskin, I just have a question to you. So what would be a downside of, for example, not having design team for the topic like slicing where so much interest? Okay, so why would be anyone say that, no, don't do that?
So there have been times that we have said authors, when we have sufficient mass of authors who have put forward documents, we say authors go in the room and figure it out. So we've taken that approach in the past. We are not suggesting that this time. We're suggesting that we be a little more structured on that and make sure we have the right people in the room. That's really the difference between the design team and the non-design team.
And I agree, because in the past, basically what would happen in the former approach, right, that several solutions will come up, and then the next question would be to marry somehow them, okay, to make a single solution, which is far more difficult than to do it like from day one, right?
And we think that there isn't necessarily agreement on what we should be doing here. And that's part of the reason why we can't say go merge documents or merge solutions.
Yeah.
That might, then that might.
Yeah, Deborah, Igor, I think hopefully this design team will be more active than Adrian's. But it is good that because it kind of, people kind of hopefully get encouraged to actually do something. And there is, and I think as far as timing goes, like Eric was concerned on, well, it's a big problem, but already we know BBF is doing it. Actually, ITU is doing it. And it would be good to liaison and get information from them to help support it. And even things like, actually, ITU had a lot of difficulty with the terms, because just to map from terminology of 3GPP to transport type of terms. So I think a design team, if they could hopefully scope it and get us kicked off in the right directions, right? And then we can communicate with the other groups that we're doing this. So hopefully it makes it go faster, that we get something by the next meeting going.
Jidong from Huawei. I'm supportive to have this kind of design team on network slicing. And one question is, what will be the expected deliverable of this design team? It's a framework document or on specific technologies like the management interface or the Android network?
I didn't understand the very last part. You said, you just ask the question part. You don't have to say the whole thing. What is the deliverable expectation?
Well, what would be the deliverable of this design team?
Perfect. That's going to be part of coming up with this design team charter. So I don't want to commit to it. I said something pretty high level at the start about, but we wanted some time to make sure that we have a good solid proposal that we bring to the working group and make sure that it makes sense. So I don't expect a protocol solution, or we don't expect a protocol solution. It would be at most a framework for the work that we're going to do here.
Okay, and then actually we have the enhanced VPN framework draft in this working group, and we hope that can also be considered as
that absolutely can be a solution to what the design team comes up
yeah, or we can base on that one to polish.
We would hope that the design team would leverage every RFC that's been published, as well as every working group document or non-working group document that's out there. We're not asking them to throw things away. We're asking to leverage as much as possible.
Okay, thank you.
Or we'll ask them, I should say. Thank you.
Switching topics now?
Yes, we're not talking slicing.
No more slicing.
Any Gs.
Hi, my name is Tariq, and I'm going to introduce you now to IP RSVP-TE. Hopefully we know something about MPLS RSVP-TE. So these are extensions to RSVP to set up point-to-point IP paths. We still call them label switched paths, but it's open for discussion. So myself and my colleague Pavan, we've worked on that. The outline of my talk is I will mention a little bit of motivation. Why are we doing and what are we trying to solve? And then we will introduce you to these IP RSVP tunnels, their creation management, how we can achieve protection fast reroute with this approach. And we will talk about shared forwarding state. I will mention the signaling extensions that we're proposing to achieve this and close with next steps. So what problem are we trying to solve? We know IP networks or networks that use IP in their forwarding, they exist. They exist in data centers. They exist in data center interconnect. And new networks are deploying IPv6 for various reasons, IoT, the address space limitation, and so on. And there are motivations even to migrate towards IP-based networks or IP-based forwarding networks for CapEx or OpEx reasons, reduction, and to reduce the complexity of learning many protocols. With that, we still need traffic engineering, and this is why we're here. We need traffic engineering because there are stringent service requirements coming forward, 5G, we've been talking about that. So we want to be able to steer over the non-shortest paths with certain guarantees. We want to be able to use the resources in the network in an optimal way. So IP RSVP-TE, what does it offer? We promise you that it works with IPv4 forwarding and IPv6 as well. It can support forward state sharing, and we are borrowing a whole bunch of features from MPLS RSVP-TE, auto bandwidth, all these features that I'm listing, we can leverage with this solution. Mainly, we also can do bandwidth traffic engineering. So how does it work? So on an egress router, we are introducing this egress address block. It's a set of addresses that reside on the egress, and RSVP is the only protocol managing these addresses. It can be one block or multiple blocks concatenated together. These addresses are not advertised in IGP necessarily, and they're not even globally routable. So they're between point-to-point, ingress to egress scoped. In terms of setting up the IP path, there's signaling that is kick-started by the ingress, typically by computing an explicit route satisfying certain constraints. It can be computed on the ingress or by a central server. Signaling is used to do the reservation if needed, but once the signaling reaches the egress, an egress address is allocated to the IP path from the block. And a note here that the same egress address can be shared between multiple IP paths. And we're going to demonstrate how that can be done. So any ingress transit or even on the egress will program their RIB with that egress address and have a binding with that IP path, specific IP path. So once the setup of the IP path is complete, now we can start tunneling packets from the ingress over the setup IP path. We can optionally insert a flow label in IPv6 per flow so that it can do proper ECMP hashing. This is an example network where we have an ingress R1 and an egress R4. We have an EAB block sitting on R4. It's a prefix. It's a V4 prefix in this example. And we have a service network behind R4 20/8. So signaling will use the ERO hop by hop with the path message, and we will use this generic label request to request an egress address to be allocated from the egress. So once the path message reaches the egress responds with a reservation message with the allocated egress address. In this example, it's 192.168.4.1. And as the ResV travels upstream, we are programming the RIB on every hop up to the head end. Once we have the IP path set up complete, the data flow, a packet trying to reach 20/8 subnet will be tunneled, encapsulated in another IP header, and you will notice that the green part has a destination address 192.168.4.1, which is nothing but the egress address that we allocated on the egress, from the egress. So the packet travels along the IP path that we signaled, and once it reaches the egress, we decapsulate the outer IP header and then forward the packet to the networks 20/8. In terms of extensions, so far we're thinking we don't need much. The generalized label request was already defined in RFC 3471. There's an LSP encoding type and switching type. We are requesting that special switching types be defined for IPv4-TE and IPv6-TE so that we can signal those IP kind of labels. The generalized label object itself will carry the egress address, so it's already suitable to carry that. We are showing here how we can achieve fast reroute with such an deployment. We have a protected IP path, an example of a link protection here with a bypass, very much similar to RFC 4090. We set up the bypass and we protect the primary path, the link, a protected link. Upon failure, you will notice in the data packet, we are pushing an extra header, the orange header here, which will take us on the bypass IP path. The orange header will be decapsulated once it reaches the merge point R3, and then the packet continues its way along the primary path towards the egress. So with this approach, we can achieve next hop protection, link protection, and next hop protection, which is node protection. So on this slide, I'm showing how we can actually share the forwarding state in the data plane between different IP paths originating from different ingresses. We have the green, blue, and red paths, you can call them, and they're all terminating on R5. R5 has an egress address block. So once we set up the green, whatever path comes first, we assign the address, egress address 192.168.5.1. The next IP path that comes in, R5 can do a validation check to see if sharing can be possible. The validation check can rely on the record route object to see if the two paths are merging towards the egress, basically the intersect and merge towards the egress. So there is a condition that R5 needs to validate. We put it down there in a statement. Once R5 determines that sharing is possible, it can assign the same egress address, in this case for the three of them. So in the data plane, they will all have the same entry, but the control plane, they have different reservations. So with this, we solicit more input from the working group. Feedback is welcome. We will be introducing additional features to signal attributes on this LSP path or IP path, and they are under consideration. Go ahead.
My name is Uma Chandari from Future Ray. Can you go to the slide, go back a little bit?
Here?
Further, where you first showed the next hop setup. Yeah, here. Next. So you are showing here a strict path, I guess, is it true?
It's an explicitly routed
It's on
path.
all,
Yes, strict path.
Strict path. What happens if it's a loose path?
So we are considering loose path as well. There are certain conditions that we have to be aware of that can create certain unexpectable loops. So with loose paths. So they are possible. You could do the loose path, but as RSVP is strictly routed, we are sticking to RSVP kind of. So we set up the path.
So you are saying only strict paths are supported
You
at
don't
this
mean
point?
strictly routed, you mean pinned.
So we are pinning the path. That's what I mean. Yes. So you can have a loose hop in the ERO that's expanded on the transit node. That's possible, but you don't want to rely on IGP routing. That's what I mean.
Oh, you don't want to rely on the.
We don't. So far, we don't want to rely on
Then how do you
IGP
do
routing.
How do you do loose path then? I didn't understand that.
Okay. So we can pin the path along the IGP path. That's possible. So if that clarifies.
No, I didn't clarify.
It didn't? Okay.
Maybe one idea I can give you, if it's a loose segment between the two nodes, you can encapsulate further. But if you don't want IGP, then you can't do anything about it.
You could still just run CSPF on that destination. Because you're going to have, since it's RSVP, you'll have constraints. And you can just run CSPF on that destination and expand. If that node has the topology information, the resource information from like OSPF-TE or ISTE.
Yeah, there is no different to any lose up. There is no different to any lose up expansion that happens on the transit today along the TE path.
The question is if what happens is the 192.168.4.1, the EAB block IP address, the loose path should have a next hop entry.
Keep in mind in RSVP-TE, your computation is based on the endpoints, not the data plane identifier. He's carrying what happens to be an IP address in the data plane identifier, but that's not used at all in the control plane state because it's just a data plane identifier.
Yes.
But
the only case that
identifier-
we've had where we use the label in the data plane is like optical.
I got that, but my question was, what happens if this data plane identifier EAB IP address gets to a node where that next hop is not installed? That's the question.
Exactly. So we are a part of the signaling, as I mentioned, is to install an entry in RIB for that egress address. So if you look at the example here, we have every hop installing a /32 host address on every hop.
So it's actually a really good question and one that we've hit inside DetNet. Because in DetNet, we can have these IP packets that sort of escape the provision path and how to deal with it.
One way to do this is you can encapsulate actually. You can encapsulate to the loose segment, which ends. And then you don't have to have this 192.168.4.1 next hop entry between these loose segments. It will take shortest path. One way to do that.
If you're doing IP, you can still escape the path no matter what you do. So as long as it's IP, you have this issue.
Yeah, but it's a good.
I actually understand more your question now. I have a context. So yes, if the packet, goes outside the path somehow, we need, we can choose a way to bring it back. Okay.
That's a good document. Good idea.
Thank you. Thank you for the feedback.
Igor Briskin, one question is how one uses such tunnels. So, like for example, if you have like a IP MPLS tunnel, right? You can use label stack and you put, let's say, service label, and on top you have, yeah.
So realizing services on top of the tunnel IP tunnels is possible today.
That's my
you carry
question.
in the destination options, whatever context you need for VPN services and so on.
So normally you would carry like a label, right? Layer 2 label.
So whatever context information you need can be carried in the IP options extensions of IP v6 or v6.
But are you talking about IPv6 or IPv4 or both?
It's possible with both, in fact.
So are you going to use, for example, header of IPv4 to put this service information? Is it?
I'm sorry, I didn't understand the question.
So basically, where exactly would put the label of the?
No. What we're saying is we're establishing the tunnel and the transport layer, and there will be services, service traffic carried by the tunnel, and it could be multiplexed on the same tunnel.
Right. So how do you demultiplex multiple services?
Yeah, it's possible. I can show you how.
Oh, okay. This is one thing, and the other thing is that there is obvious similarity with PBBTE. Okay, there are reasons why it didn't succeed. Okay, so one thing is that basically this big overhead, especially if you want to nest tunnels within tunnels, right? So
less tunnels. Sorry.
Nested
tunnels, you mean?
Yeah.
Okay. IP and IP encapsulator, is that what you're saying?
Yeah.
Okay, but if you look at SRv6, they are doing a lot of encapsulations as well.
But it's basically overhead over overhead. IP, it's every encapsulation, it will take the entire IP header, right?
Even in SRv6 and SRv6 Plus, they are doing IP and IP encapsulations. So.
Okay.
This does bring up a point that I was going to raise at some point, that you could do this even without the encapsulation, and there could be value there, particularly if you're looking at it in the context of the DET network, which uses more headers than just the destination. And I could see this being very useful there. And the expectation is DetNet isn't going to do control plane extensions, but sort of come up with frameworks and requirements and bring them here. So if you added the support for the DetNet IP layer and the type of traffic classification that it can do, you'll be ahead of that group. And that would be very good. And that's with either chair hat on.
So that's definitely good, feedback, and we're willing to look into that and encompass the requirements from DetNet if we can. And not needing to encapsulations is a good thing. So we're willing to look into that, definitely.
Hi, Dhruv here. First question would be, can you speak a little bit more about how the EAB block you will be maintaining on every egress? So your thought is that all over your edges of the network, you will assign separate blocks and or address block. And where would that space be coming from, especially from the IPv4 things? What are your thoughts on that? Is it like some special addresses and then you're further dividing them?
Right. So in the let me see in the previous. So yeah, we are saying that these address blocks, they don't need to be routable. They're not advertised in IGP. They can be from the private address space, like the well-known private address space in IPv6 or IPv4. And they can grow dynamically. They don't have to be statically pre-provisioned. So on-demand resizing is possible.
Well, let's discuss that. One small thing, compare this to pure OpenFlow, and I'm just doing IP forwarding in OpenFlow using a controller and doing bandwidth management there. Compare this, why I should use this.
Oh, definitely. I mean, the idea of doing distributed bandwidth traffic engineering. So now you can do bandwidth engineering distributively, preemption, FRR, all the rich features of its marketing now, but you'll be able to. Did I?
Okay. You have 3 minutes for the last two questions, or 3 questions, EFP or Zinc as well.
Okay. Jean-Emerick, so to get a quick one, I see that for fast reroute, we rely only on RFC 4090 or 09. Have you considered looking at 4873 segment recovery within the MPLS? Because it's just another switching cap within the MPLS. So why this exception with respect to
no specific bias? No specific bias. It's just because in the packet world, 4090 was more implemented.
Yeah, I see where it's coming from. So have you considered other than legacy to look at it, or just convenient to rely on MPLS fast reroute?
Maybe it's convenient, but we're open to look into 4873 and 72. Yeah.
Okay, thank you.
Adrian Farrell, apologies for trying to consume all this from your presentation instead of reading the draft. What I think I understand is that you are doing a global context, destination assigned, non-swappable label.
Not global though. It's what we said is, I mean, there was but it's between the ingress and egress along the path. These are the only nodes that.
Yeah, sure. But it is global context because these two paths might cross, so that the EA had better be globally unique. Otherwise, when the paths cross, the packet will get cross-routed.
Okay, yeah.
So the only difference I see between MPLS and this is the size of your label.
It's
if you believe that 20 bits is not enough, then I would suggest you must limit this only to IPv6.
Do you see issue in IPv4?
Well, apart from the political, we shall not work on IPv4 extensions. If you believe that 20 bits is not enough, you should limit this to IPv6.
Okay.
There is, of course, the out for them to say that they're supporting the DetNet data plane, which includes v4 and v6. By the way, it uses a lot more bits.
Thanks.
This is an early draft, clearly.
Yes, it is.
There's, if you don't mind, take it to the list.
I just want to make a comment on this regard for this.
If you don't mind, take it to the list. Thanks. It would be worthwhile to see, even though we had good discussion, it'd be worthwhile to see how many people think that this is a topic we should be working on. I'm not saying accept this is a working group draft. Is this a topic we want to be working on? IP traffic engineering. There's a few hands, not a huge amount. How many think we should not be working on it? 0. That's useful information. Thank you. We're a little bit, we have like 5 minutes for the last person, so please come up.
Thank you.
We've managed to use all the time.
Thanks for giving me the chance. I'll try to be quick. Okay, my name is Bin Liu. This is a new work. We call it ICANN, Instant Congestion Assessment Network. And we considered it as a kind of data plane traffic engineering technology in terms of tiers context. And please note that although the other draft only has one author, which is me, but it is actually a very solid teamwork, including both solution design and the prototype development. We've been working on this for more than 1 year. Sorry. Okay, for what's the problem? Problem 1, the network is always unbalanced in real situation. Okay, current technology such as ECMP, UCMP cannot handle it very well. Challenge 2, the traffic is so dynamic that traditional traffic engineering cannot adapt to the traffic in the microscope. So we propose the ICANN solution. First, we still rely on the centralized controller to calculate multiple paths for each pair of ingress router and egress router. This could be done in a fairly slow control loop, say at fastest maybe minutes level or even longer. And after that, the job will handle to the routers, and the routers will do the path congestion assessment, and then it will decide which flow need to be switched from one path to another. And this process is totally done by the routers by themselves without any interference of the controller. So this could be done in a very fast manner, which is tens of millisecond level. And the intermediate routers don't need to participate in the process. It's totally done by the end-to-end. Only the egress router and the ingress router and the egress router. So with this technology, for different purposes, there could be 3 use cases. The first one is of course, the guaranteed network load balance. And we have developed a hardware router-based prototype for this use case. And we can also do SLA assurance as well, and high availability. And for deploying scenario, the ICANN is basically agnostic to the underlay technologies, whether it's segment routing or is tunneling technologies, can all benefit from this mechanism. Okay, this is the laboratory test result. In short, and according to our test, 30% through network throughput increment is done. So which is quite a good result. And this is done without any hardware expansion. It's totally done by the software upgrade.
Can you summarize?
Yeah, and I also have some backup slides for the technical details. Yeah, only a hint. So you can read by yourself. So we want to know whether you think the solved problem is valuable or the solution is in the right way. Thanks.
So we really only have time for one point, which is that we've seen, I think this has been presented in multiple groups.
Mhm.
And so it's a bit of a question of where does this work belong or belong at all?
Yeah, in my mind, TEAS is the first place.
Okay, so this is something we should definitely talk about with our AD. And I think that's going to be a significant point. Obviously, it's early. We do want comments on the list. Michael, since you've been patient, please, a quick.
Yeah, my name is Michael Schaffens. In this specific case, I speak as a member of the TSV area directorate. So please be aware if you do something like that on millisecond time scale, you can interact with the congestion control loop on the end systems. And you have to look at that very early in the design. Because as I said, at this time scale, you have several other control loops in the overall system. And you have to avoid early that the control loops interact. So you have to look at the congestion control loops.
Okay, thank you.
Okay, thanks.
With that, thank you very much, and we will see you at the next IETF. We're at Singapore. So thank you very much. No. I'm telling you.